I'll be taking you through my KiCad assignment. So this is a schematic of the Arduino board. So I'm going to show you my component placements and explain um, their functions over there. So this is my, I'm going to use two Atmegas. Okay, so I have my Atmega 32 8B, which is U4, and then which is the main brain actually, okay, for the board. And then there's going to be my complementary Atmega 16 U2. Okay, um, so this second chip, which is the U3, and yeah, the U3, it acts as my USB to serial converter. So my computer literally can program the Atmega 32 8P, okay, through a USB connection. So the for the power side, I used yeah, I used two voltage regulators. Okay, so I have, which I labeled the U2 and then U6 respectively. So the U2 actually steps down the input voltage down to 3.3, okay, and then the second one, which is the U6 regulates, it's a 3.3 volt regulator actually, and it connects to the USB power line. Take you through how the power comes through. I power my board, my whole board. So my power comes in through the barrel jack, which is the J2 connector, and it passes through my diode, which I labeled D4. Okay, so um, the diode actually protects my board from reverse polarity. Okay, and then I place a decoupling capacitors, as you can see, my C1, my C2, and my C3 respectively. For timing, for my timing, um, instead of a separate crystal and two capacitors, okay, I used a ceramic resonator. Right, so this is it. Yeah, I used a ceramic resonator over here, mm, which I labeled Y2, as you can see. And then I connected it to my XTAL1 and then my XTAL2. Okay, so it controls the clock and speed of the chip. So for my resets, I added the SW2, which is the a push button switch, okay, along with a pull up resistor, network. So along with the pull up resistor network. So for the USB side, let's go to the USB side actually. Yeah. So for my USB side, I placed J1 and the USB B connector, okay, and F1, which is the resettable fuse to protect the power line, okay, for my board. And then I have my two variables, which is the variable, the RV2 and then the RV3, to protect my data lines from voltage spikes. Okay, so finally, I broke out the digital, analog, and power pins using the headers, the G1, the G3, and yeah, and my G4, my G8. Yeah, basically that's what I did. So after wiring everything, you go to your electrical rules checker to actually check, you run your ERC. Okay, so as you can see, I have one error. Let me go to check what that error is. Okay, so let me close it. Then Normally it's indicated with one those red arrows. Okay, so in order not to waste time, I'll run my ERC again, and then it told me that the error, mostly it tells us where the error is. So it's telling me that my symbol U7 has input power pins and units. Okay, so the that are not placed. Okay, so I'll have to rectify that. Okay, so as you can see now, we don't have any warning signs or any critical warning signs. So from here, I'll go to my PCB editor here. So I'm opening my PCB board and editor. But before that, let me bring this to your notice. Always when we are picking a component, let's say the shortcut is A, it gives us a pop-up menu. So when we want to pick any um, components, you just click on it. But you always go to the footprint and pick the footprint of your choice. Either you want it through hole or um, the one soldiered on it. Okay. So when you choose the appropriate footprint, then you click on OK. You click on OK. Then you place your components. So this is how to pick a component and then place them. But since I've already done that, I don't think there's any for it. Yeah. So I move on to my PCB editor. Yeah. So originally KiCad actually shows this in a rat's net form. Okay. So there's small wires and showing us where the components are supposed to be connected to which one. You get it. Yeah. And I actually placed my Atmega 32 8P at the center of the board. You know, I intentionally copied the real design, okay, so that it will make my work much more easier. So I placed the resonator. Yeah, my resonator is placed very close to the XTAL for shorter routing or wiring. Okay, so um, you know, the original Arduino design is actually tested and proven. So me copying the their design layout or something, I also know that it's going to work. So I just wanted to reduce any form of signal problem or issues. So I also set the board outline and chose a two layer. I'm having the copper layer on the top and then another one on the bottom. Plus a silk screen at the edges. Okay, that's the edges of the cut that I made. And so after placing all the parts that's all the parts that I'm having here, and I connected the right net line with the real copper traces. Okay, and this is called routing. So for our routing, we could basically just tap on this. So with the routing, we take the route track from here. Then we go to what we want to route, like or where we want to routing our wires or our lines. So you select it. It automatically gives you where next you would want to end your route track. Okay. So then you click on it. Yeah, I've already done that too. Okay. So this is how you do it for each and every route. And okay, that's the route track. And we can see here that I place my resonator is very much close to my XTAL, the one into, so that I don't um, hinder or like disrupt the signal. So the longer the routing is to the resonator, the noisier the signal. Okay, yeah. So yeah, this is how I did my routing. Then we move on to the 3D view. So this is how I my 3D view look like. Okay. So as you can tell, it looks exactly like the Arduino Uno that is on the market. Okay. So someone will want to change the color of how this looks. So this with that one you go to the we have the front marks and then the back marks. So you double click, then you choose the color tone that you want, then you okay. So with that one it changes. See, I only changed the front, so the back remains the same, right? Yeah. Some of the components that I chose because of the footprint, some are through holes and some are just soldered on the board. Okay. Yeah. This is how it looks like. My end product for fabrication. So I'm going to send this for fabrication. Cover the schematic, the PCB, and then the final product. Thank you very much for watching. Bye.